Hi, this is Russ Anderson. Today we're going to talk about incident analysis based on video footage. That could be a plane or car crash, or maybe something less dramatic. This tutorial is specific to incident analysis, not match moving for filmmaking. The idea is that we have footage from a surveillance camera or maybe from the cell phones of witnesses, and we want to analyze it to determine where the vehicles were moving, at what speed they were moving, and whether they turned or braked suddenly, for example. Here we have a sample shot that might be from an incident where an aircraft is taxiing. Obviously this is some synthetic footage for legal reasons. For accuracy and robustness, we need to have 3D survey data from the scene. For example, a GPS location for the poles here and the signs and other visible features. We'll also need a 3D model of the vehicles that are involved. Our first main step is to identify how the camera is positioned and oriented versus the ground truth. As I scrub through the shot, you see a slight jiggle that is typical of surveillance footage, where the camera's on poles or bouncing a little due to building vibrations. So we're going to do a tripod type solve to determine exactly what that is. We'll start with 2D supervised tracking of the scene and match the trackers to 3D measurements from the real world. We always need measurements at least to set the scaling of the scene. A full set of measurements helps create and confirm the accuracy. We'll then solve the camera in SynthEyes. With an essentially fixed camera, no 3D information can be produced to locate objects out in the scene. We can just determine the pan, tilt, and roll of the camera. That's why we needed the 3D measurements in the first place. It's also possible to work with moving cameras. For example, the plane crash in South Korea that was observed by dash cams in moving taxis. That's a little more complicated, but produces more data. Once the camera has been determined, we'll work on the vehicle. Again, we'll use supervised tracking, and we'll match it up to 3D data. In this case, working from a 3D model for the plane. If that model isn't coming from the vehicle manufacturer, you'll want to confirm the accuracy of the model. While it's possible to work without a model, using only a single distance measurement for scale, again, the model makes the process more robust and accurate. For example, if you have the 3D model, you can determine vehicle position even if the vehicle is stationary, which isn't possible without the model. Just a warning, due to licensing restrictions, we can't give you the licensed 3D model here. Once we've done the supervised tracking and set up the 3D information, we solve for the vehicle's position and velocity relative to the ground. Overall, this process relies heavily on supervised tracking. This tutorial is not about supervised tracking, which is a whole subject in its own right. You'll see some supervised tracking, but to learn it, you'll need to see the supervised tracking tutorials. You'll also typically need to deal with lens distortion and maybe rolling shutter. This isn't a tutorial on those either, even though they can be essential to generating accurate results. If at all possible, it's best to have the actual camera in hand for testing, or at least information on the manufacturer and model, especially if it's a wide-angle lens that's involved. There's no magic set of buttons to push that applies for every shot. Every shot poses its own challenges that have to be addressed accordingly. Now we're ready to start tracking. Before we go and start wildly creating trackers all over the place, let's just take a look ahead. And you can see this is a overhead 3D Google image of the airport here. And we're going to be using this as the source of the 3D information. You notice that this is obviously limitations since it's a flat map, and there's in fact no altitude information at all from it. So that is a limitation, but what I've done is gone through this and identified some features that I can see both in the overhead map and in the actual scene itself, the video imagery. So these locations that I can identify in both places are the things that I'm going to want to do the supervised tracking on. There's no point in tracking other things where you can't locate the 3D information. So I'll point out, normally really what you want to be doing is using some GPS data that has actual altitude information as well. In the case of some of these poles, maybe you need to get out and do some actual measurements of the height of those poles to generate some actual height information as well. So onto our supervised tracking, we'll go to the tracking panel and turn on the little magic wand there. So one of the things that's I'd identified to track is this last post. So now I'm just using the middle mouse wheel here to just roll through frame by frame. And you can see that as I go in, eventually the airplane starts to come in front of it. So I could go and just animate the size of this tracker a little bit and kind of postpone the inevitable a little bit. And eventually at some point it gets to be more trouble than it's worth to keep on repositioning that. So I'm just going to temporarily turn it off, wait until the plane has gone by, and now I'm going to turn it back on. Nothing's happened so far, so my two choices are either hold down the Z key and go click out in the viewport, or I can just go and wiggle a little in the little mini tracker view while holding down the mouse, and that causes the tracker to reappear. So I can now resume tracking. See, I still have a little bit of the tail there, so I'm going to let that get all the way out. Its position still looks okay, so I'm just going to right click and set another key at this frame as well for the further tracking. And now maybe I just hit the play and let it go through the rest of the shot. Now this is really a homogeneous sort of shot. There's really no long-term shift in this over the course of the shot. There are more advanced tracking, supervised tracking techniques that are useful, when the actual feature being tracked is changing over the length of the shot. You can use some of the other controls there. But that's not really the subject here. We'll just take our initial track through it, and we'll hit the lock because we are done with it. And now we can go on to something else. Maybe we'll take the corner of this sign over there, let it run through, just keeping an eye on it. There goes our plane. So I'm just using the middle mouse to run backwards, and let's see where that is. So it's really pretty good up to there. So at that point, let's just turn it off. Again, let the plane fly by. Turn it back on. And let it roll through the rest of the shot. So we get to do this basically repeatedly for these different features. Okay, we'll do this little marker spot down here. You can see I can change the shape of this a little to match what we're looking at. Again, we'll just let it run through there. Here comes the plane. We'll just turn that off, let the plane go by, including the shadow. I'm just wiggling there to get that back on. We still have some of the shadow in the area there. So there's really gets to be good. I'll point out I can use the arrow keys on the keyboard to do this adjustment also. These are little nudge keys. So you can do most of this just by the keyboard if you want. This is using the comma and dot to go through the shot, forwards and back. Like I said, the arrow keys on the number pad, that is, those let you do those little nudges. And once the plane's fully out of the way, we'll just let that run through. So you can see how exciting this is. So I am going to just put a hold on things now and run through a bunch of these other locations, and then I will be right back. Okay, so now you can see that I've added a bunch of trackers throughout the entire scene. Now you can take a look at what sort of coverage you have by switching over to the graphs view. And I'll switch first to the tracks here, and you can see, a bar for when each tracker is available and visible to be able to assess, where you have enough trackers, where you don't. And in fact, there's even over here in the curves part of this, a curve that you can turn on that gives you literally the number of trackers on each frame. You can see we're 11, and I can scrub through and see where I might need to add some more trackers. So, you can see it gets down to 9 there. But that's a reasonable number of trackers, especially since this is a tripod type shot. We're not looking for a full 3D solve. So this is just 2 ways that you can take a look at whether you have enough trackers in the scene and where you need to do some further work. So once we've got this, we've got the 2D tracking done, and we're ready to put the 3D information into it. So if you recall from earlier, we have our Google overhead view that has annotated coordinates on it. And these annotated coordinates are what we were going to be entering here. So if I click to the coordinates panel, I've got a tracker selected, and up here is where I'm going to enter this data. So I'm actually going to be referring to another version of this map off screen, so I can look at the numbers. And so I'm just going to type those in, 310, 447, and enter those in. And now I can use the up arrow and down arrow keys to sequence through the trackers to do this. So got some more values to put in. And I'll point out that you can put this data into a file and import the file if you like as well. If you do that, you just have to make sure that you've got the right tracker names for the data that goes with it. But if you wanted to put it into a separate file and then import it en masse, then there is a way to do that from the file import menu as well. In this case, I'm just going to type it in. So I'm going to do that right here for a second and put you on pause. I'll be right back. Okay, so now I've got my values all entered here, and I'll just roll through these a bit. One thing that I'll point out, if you're working from GPS data, sometimes people have a tendency to want to work with some full 6 or 7 digit number, and that's really not terribly convenient and can actually wind up creating some accuracy problems down the line. So it's actually wiser just to subtract and offset from those values so that you have some reasonable, 3-4 digit sorts of numbers to work with within SynthEyes. So save yourself some typing and trying to figure out where numbers really are if you do that. So with all these values entered, we need to do a couple more things. First, we're going to mark all those trackers as seed locations and as lock points. And that is telling it that you want to be using these values that you've entered to help figure out where the camera is. Now, there is one kind of little detail to this so far that in the map, Photoshop numbers things down from the top, which means you got a left-handed coordinate system. So that's a bit silly and not terribly useful. So, for this particular use. So we want to flip the y coordinates in the other direction. So we're going to use Cynthia to do that. It's our smart assistant for SynthEyes, which is great at this sort of thing. So I'm just copying and pasting in the little command that does that. For each tracker, make the tracker's Y lock position, 1519 minus the tracker's existing Y lock position. And that 1519 is the vertical height of the image minus 1. So if I do that, presto, it just flipped those values around. And one thing you'll also see is that we're using these values, from Photoshop measured in pixels as ground coordinates. And, really you're going to want to have some real ground truth sort of values to it. So if you, get the right scaling factor for the map imagery that you're using, you can scale the values using Cynthia very similarly. So it's kind of a handy little fix-it sort of tool. With these values now in place and going in the right direction, we're ready to do the solving part. To do the solve, we're now going to go over to the solver panel, and we want to set the solver up to use those coordinates that we've set up on each individual tracker. So we're going to use the from seed points mode. We're also going to make a little technical adjustment that says that the overall side of the world, kind of in the under the dome sense, is around 2000. So that is based on the size of these values that we're feeding in over here for the coordinates. Now, the solving process is a bit less stable than normal because it is literally 100% flat. There's no points with any non-zero height at all. So we're going to do a small adjustment or two, turn on slow but sure and constrain to make sure that we keep on getting a decent solution despite that deficiency in what our overall plan was to work from the 2D data. So now we're ready to go and do the solve. Just hit click go, and there's not really too much data to worry about, so we got to solve quite quickly. And when you look in the camera view down here, you'll see there's little markers that indicate where the points are that are pretty much centered up in the 2D tracking locations. You get a numeric value that reflects how much of a difference there is between the 3D location that's been computed and the 2D location on average. That's an RMS value is up here. So at 3.3 pixels, that's a fairly large error by usual sorts of standards, and that kind of reflects our overall Google Maps approach here. We would really like to do better for filmmaking. Usually we get that down well under a single pixel. But to do that, you may also have to worry about lens distortion on that as well. But for our purposes here, this is going to be good enough. If we go and zoom in on the camera down here, you'll see that it's actually got a whole little set of motions to it. That's because we're computing the position of the camera on each frame individually. So based on the little details of where everything is, a little bit of jitter anywhere, that reflects itself as jitter in the motion of the camera. And that's not something that's really happening in the physical world. Generally, if the camera's up on a post, there might actually be some of this. But here, that's not really what's going on. And you can go and look and see that, there's basically the equivalent of a couple of pixels of change. I'm looking down in the lower left-hand corner here. As I move around, you see the equivalent position in the environment. And that's, measured in the units that we used for assigning to the trackers. So it's roughly pixels. And, there's definitely a couple of pixels worth of jitter to the camera position. So the question is, well, is there something sensible to do about that if we want to calm that down? Because that will, in fact, be reflected in the position of the aircraft eventually. So again, I'm going to bring up SynthEyes and give it something useful to do, which is this command here, which is make camera 1 seed position camera 1's average position. So we're just going to average that all out. And now we're going to go bring up the solver locking panel and say that we want to lock the position to that computed value. Here's the computed value here that was just set up by SynthEyes. We do want to be sure to do that at the beginning of the shot, by the way. So now it's going to be locked to that particular value throughout the shot, and we can just hit the solve again. And now if we zoom back into this, you'll see that it's not going anywhere at all. We can even go over to the graph editor and take a look at the camera there. So here are the coordinates. And you can see that the angles are now changing, but the position information is very rock solid. So back to the camera view here. So basically, we've had SynthEyes figure out what's going on with this small degree of motion in the camera, and that way it won't be affecting the position of the aircraft. Using Google Maps information as a reference, has the disadvantage that you don't get any height information for it. But if your environment really is very flat, like this aircraft scene, you can pick up a nice advantage for cross-checking what you've done. And I just wanted to show that here. So we're going to go over to the 3D room, and I'm just going to zoom out using the middle mouse to get the entire scene there. And we're going to create a plane sort of the right size, and then we're going to go over to the panel and directly enter the size. Now this is the size of the image in pixels, and we're using pixels as our unit of measure here in this particular example. So I just made the plane that I created exactly the same size as the reference image from Google Maps that we're using. So if you had a correspondence between the pixel size and the real world size, you'd want to be using the real world size for this because we're creating it in the 3D environment. So to position this accurately, we're going to go to this and turn on edit pivots so that we can move this pivot point down to the corner, so we know exactly where we want that. And I just zoom in a little bit so that it then will snap to that corner. You always want to be sure to turn the edit pivots back off, by the way. So now we can just enter 0, 0, because that's what we want. We want that corner right at the origin. So we have this ground plane set up at exactly in the same location that corresponds to our coordinate system. And now we can bring in our annotated map as a texture and apply that to that plane. So now if I go over to the perspective view, I lock onto that. You see the plane is selected there. I'm going to unselect it so there's not the red highlighting. And now I can turn on and off that plane. And as I do that, you can look at individual features and see to what extent the scene is lined up or not all throughout the shot. And you can do that. You can go to any of the frames and see just how well it lines up. Now, because we didn't have any of the height information for anything, This isn't the world's greatest match. It's not bad, but it's not great either. But you can go and look at various things and see how well they line up. So, you get a numeric value of how well it lines up. This, if the world that you're looking at, the scene that you're looking at is really sufficiently flat, this gives you a nice cross-check also to get a real visual feel for how well things do line up. You'll also see some techniques for looking at the quality of the tracking in the later portions of the second half of this tutorial, where we determine the airplane's path. So please follow me to that second half now. Thanks for watching so far.